Okay, exam 2, problem 6. We have a 50-meter long bridge with a mass of 10,000 kilograms and has two cars on it. The first car has a mass of 1,500 kilograms centered 10 meters to the right of the center of the bridge. The second car has a mass of 750 kilograms centered 15 meters to the left of the center of the bridge. If the center of mass for the bridge is at its middle and it's only supported on each end, determine the total force on the supports at each end of the bridge. Draw a diagram of the bridge and be sure to clearly label all the forces. Well, I've drawn my diagram. I'm going to paste it in, all right, and explain all the bits and pieces of the diagram. So over here, right, this is the force from the left support on the bridge. This is the force from the right support on the bridge. This is the weight of the bridge. This is the weight of car 1, and it is 10 meters away from the middle. And this is the weight of car 2, and it is 15 meters away from the middle. Right? All right? Is that clear? Clear to everybody? All right, this is my diagram of the bridge. And I may go back in and add the 15 meters and the 10 meters. We'll have to see. All right, so the question is, what are the forces at each end? All right, so what are the two equations we have to work with? We've got the torques, and we've got the sum of the forces equal to 0. Right? So we start with the sum of the forces. FL minus, right, because they're pointing down, minus the weight of car 2, minus, I'm writing them in this order simply because that's the order they're in the figure, plus F right, all that adds up to 0. All right, and what do we know out of this? We know the weight of the bridge is 10,000 kilograms times 9.8 meters per second squared, right? We know the weight of car 1 is 1,500 kilograms times 9.8 meters per second squared. All right. Let's go ahead and multiply these out. So this is 980. Right. All right, so 10,000 times 9.8 is 98,000 kilograms meters per second squared. All right, and down here we have 1,500 times 9.8. Okay, 1,500 times 9.8, so the weight of car 1 is 14.7. 14.7 newtons. So kilogram meters per second squared is a newton, right? And now the weight of car 2, if I remember correctly, 750 kilograms. So 750 kilograms times 9.8 meters per second squared gives us 750 times 9.8, 7350. 50 newtons, right? Okay, so if we sum all of those up, we get 120,050. Okay, so we could rewrite that first equation as FL plus FR equals, what was that number again? 120,050. 20,050 newtons, right? 120,050 newtons. All right, so that's the first equation. The sum total of the forces going up have to equal the total force going down. Now, the next equation is the torques, right? Because we've got still two unknowns, and so let's pick a point for the torques. Now, if we pick the middle, that's fine, but that leaves us with two unknowns, and we don't make progress as quickly. So what I'm going to do is I'm going to pick the pivot point as over here on the left. All right, and so that is 10 meters. from here to there is 25 meters. From here to there is 35 meters. And from here all the way to the end is 50 meters. Okay. Sorry for the zoom. All right. So that means if we take the torque about that end, all right. So all the weights cause a cause a torque that's negative because they cause a clockwise rotation about the pivot point on the left, and then the force from the other side causes a positive torque because it causes a counterclockwise rotation. So we've got WC2, right, minus WC2 times the distance it's at, which is 10 meters, right, minus WB times the distance it's at, which is 25 meters, minus WC1 times the distance it's at, which is 35 meters, plus FR times 50 meters equals 0. All right? All right, so let's go back and look at here. This is the bridge. This is car 1. This is car 2. The bridge is at a distance of 25 meters. Car 1 is at 35 meters. Car 2 is at 10 meters. And so if we want all these torques, this torque times that, all right, get those real quick. Okay, so we've got minus 2.45 million is, well, let's do them in order. So this is minus the torque due to car 2. Torque due to car 2, 73,500 Newton meters. 73,500 Newton meters. Minus the torque due to the bridge itself, 2.45 million, so 2,450,000 Newton meters. Minus the torque due to car 1 is 514,500, so 514,500 Newton meters, right? Plus FR times 50 meters equals 0, right? So I'm going to take all of this stuff to the other side. I'm going to divide by 50. And I'm going to get FR equals, okay. So let's add up all these torques. That's the sum of the torques. And we want to divide that by 50 meters. So 60,760. 60,760 newtons is FR. All right. Now we've got FL plus FR, right? We've got FL equals 120,050 newtons minus FR equals, okay, 120,050 minus 60,760 is 59,290 newtons. So now we have the weight on the right and the weight on the left, and we are done with problem 6.